Today we're going to talk about degrees and radians, basic trig functions, helpful triangles. We're going to talk about how to deal with negative or obtuse angles. We're going to talk about a mnemonic called CAST that helps us to remember where trig functions are positive. Then we'll look at additional trig identities. Angles can be measured in either degrees or radians, and pi radians is 180 degrees. So if we wanted to know how many degrees there were in pi over 3 radians, we'd write pi over 3 radians is equal to 180 degrees over 3, which is 60 degrees. This is the basic triangle that we can use to help us understand sine, cosine, and tan. We have an angle here, theta, and the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tan of theta is the opposite divided by the adjacent. The tan of theta also can be written as sine of theta divided by cosine of theta. There's a couple of helpful triangles we can use to help us calculate sines, cosines, and tans of angles. The one on the left is a pi over 4 right angle triangle. And if, for example, we wanted to look at the sine of pi over 4, we take the opposite, divide by the hypotenuse. And this would give us 1 over the square root of 2. Using the triangle on the right, if we wanted to look at, say, the cosine of pi over 3, then we choose pi over 3, and then the cosine would be the adjacent over the hypotenuse. And we write that as 1 over 2, or a half. If we have negative or obtuse angles, we can extend this idea. So let's look at a situation where we have a point P, which has coordinates x and y, and that's radius r, and the angle is theta. We measure the angle from the positive x-axis, and this point then has a y-coordinate right here and an x-coordinate right here, and then the sine is a y-coordinate divided by the radius, and the cosine is the x-coordinate divided by the radius, and the tan is the ratio of y over x. If we want to, we can extend this idea to look at an animation of what happens as we move around the unit circle. And here we see the angle going from 0 to 2 pi, and then the y-coordinate is plotted out on the right hand side of the animation. And notice the radius of the circle is 100. So what we're getting is we're getting a graph of y equals 100 times the sine of the angle. And so here we see the plot of sine and cosine. Notice that the sine function in blue is odd. So sine of minus x is equal to minus sine of x. On the other hand, the cosine function is even, so we have that the cosine of minus x is equal to the cosine of x. If we want to remember where sine, cosine, and tan are positive, we can look at the coordinate axes, and I'm putting the labels on them, and these describe the angle it would take to rotate that distance. And so remember C, A, S, and T. In the quadrant 4, only the cosine is positive. In the first quadrant, all trig functions are positive, sine, cosine, and tan. In the second quadrant, only sine is, and in the third one, only tan is. And if you don't like CAST, you can remember all students take calculus. There's some trig identities that are quite useful to remember. One is that the sine of A plus B is sine A cos B plus cos A sine B. And another is that the cosine of A plus B is cos A cos B minus sine A sine B. So for example, if we wanted to calculate the cosine of 2x, we could use a second formula, but we'd have to set A equals B is equal to x. And then using that second formula, we'd see that cos of 2x is cos squared of x minus sine squared of x. If we looked at sine of x minus y, we'd use the first formula, but then we'd set A is equal to x and B is equal to minus y. And so our formula would be sine of x cosine of minus y plus cosine of x sine of minus y. And we can work on this a little more because remember cosine is an even function and sine is an odd function. So this will give us sine of x cosine of y minus cosine of x times sine of y. And that's our answer. So there are additional trig identities. Cosecant is 1 over sine, secant is 1 over cos, cotan is 1 over tan. If we remember the Pythagorean theorem, x squared plus y squared is equal to r squared, then we can get an interesting relationship between sine and cosine. In particular, if we take this formula and we divide through by r squared, then we have x squared over r squared, or we can write that as x over r squared, plus y over r squared is equal to 1. And if we remember the formulas for sine and cosine, this gives us cos squared of theta plus sine squared of theta is equal to 1. This is a useful formula to remember. We can work with this a little bit. Providing cos theta is not equal to 0, we can divide through by cosine squared of theta, and then we'd have cos squared theta over cos squared theta plus sine squared theta over cos squared theta is equal to 1 over cos squared theta. And we recognize the first thing as 1, the second as tan squared of theta, and the third thing as secant squared theta. So we have 1 plus tan squared theta is equal to secant squared theta. There's another similar formula that we can find by dividing through by sine squared of theta. And I urge you to try that and see what you get. In summary, we've looked at degrees and radians. We've worked out some basic trig functions. We've used helpful triangles to work out sine, cosine, and tan. And we've extended our concept to deal with negative and obtuse angles. We've used cast to try to understand where the trig functions are positive. And then we've worked on additional trig identities.